Hello everybody, this is Zareian from Power Electrical Developing Advanced Research Group. In this short training video, I'm gonna talk about voltage stability control in Power DC Microgrid. In this video, I wanna talk about how to control ESS charging and discharging mode with a buck boost converter. Also, in the next step, I wanna talk about how to control voltage stability in Power DC Microgrid. Actually, in this video, I want to show you how to control energy storage with the aim of control the DC voltage link via a bidirectional buck boost converter. For more details and talk about details of component of this simulation, let's go to simulation and talk about details of this simulation. If you want to call all of these simulations files in your Matlab software, it's enough to copy this address and paste it in your Matlab software by pressing the key enter. All of these simulations files are called here. In order to open the main simulation file, it's enough to double click on the simulation file. As you can see in this video, this is a power microgrid, DC power microgrid, where energy storage is connected to DC link by a buck boost bidirectional converter. Also, in the other side of this simulation, we are encounter with a PV system that is connected to DC link by a boost converter. As you know, the main important issue in each type of DC power network is controlling stability of the DC voltage in DC link. So we need a slack bus, or we need a controlling generation voltage bus to control the voltage in DC link. For example, in this simulation, we consider these energy storage generation units to control the DC voltage link by absorbing air and injected the power to the DC link power network for different scenario of the fault in the system. For example, we consider a resistance, low resistance to ground for simulation of the fault, short circuit fault to the system when a short circuit fault happened to system between second of 2 and 2.2. Duality of this issue is in AC microgrid, where a slack bus in AC microgrid or grid forming inverter is responsible for controlling the voltage and frequency in AC microgrid. So as you can see here, duality of this issue is in DC microgrid, where a bus is responsible for controlling the DC voltage link in the power microgrid. So the question is here, how we can control the voltage DC link? In order to control the voltage DC link, we use a buck boost bidirectional converter with two different operating modes. If you open this simulation, as you can see here, this is the circuit of control of the buck boost converter. When we have two switch, this is a switch that works with buck converter, and this is the switching that is used for boost converter. By switching between two switch, we can control, we can increase or decrease the voltage of the energy storage. For example, when we want to control the energy storage and absorb the energy from the network, we need to work with a buck converter mode. When a battery energy storage work in charging mode. Also, when we want to work on discharging mode, we need to work with boost converter mode and try to control on switching with the control of the primary that is located here. For example, as you can see, this primary control work in two mode of the current controller and voltage controller. So if you want to control a current controller, you need to specify the reference current here and put the switching state. For example, as you can see here, we have two state of operation here. This is a block of switching mode. When 0 is a current mode and value of number 1 is used for controlling the voltage mode. So as you can see in this simulation, we want to control the voltage DC link. So we put this state on one value. By this type of situation of control, we can control the switching by voltage control when the voltage reference is defined here. The voltage is 300 is you consider for DC link. So we want to control this DC link during of different disturbance and different operation mode of the system. Let to show you if you run this simulation, what happened to operation of this simulation for power microgrid. If you run this simulation, you can see the simulation result in data acquisition part. If you open this part, you can see during of these operation, we have a voltage that is stable in all time of operation in per unit. As you can see here, we use a coefficient factors where a V nominal DC is considered here 300. Let me show you. If you open this file and look at the different parameters that is used for this simulation, we specified nominal voltage as a 300 here, and we use this simulation with per unit format. And as you can see, during of the fault, when the fault is happen at second 2, transition between 2 and 2.2, the DC link is stable during all time of the operation. Also, you can see another part of the simulation by double click here. So you can see the injected power by the energy storage here. As you can see, this is a power that is injected to the system by battery. Also, this is voltage of battery. As you can see here, is used for control of the voltage and current of the battery. As you can see, the current of the battery has chattering for controlling the voltage in all time of the operation by the system. Also, you can see PV system output and different parameters that is related to the PV system. You can observe them here. As you can see here, this is the transient of irradiance. However, according to this transient, we have not any chattering in DC voltage link, and we can pass the condition of transition in irradiance, and also we can pass the condition of short circuit fault in the system, so we can control DC voltage link at all time of the simulation and operation by a DC power microgrid. So as you can see here, we can control the DC voltage link using a buck boost bidirectional control, where a control mode of these buck boost converter is selected for controlling the voltage, where the voltage reference control is defined here, and we can control the DC voltage link by absorbing or inject the power to the DC link. If you want to use this simulation or change this simulation according to your desired model related to your project, you can go to our Telegram channel with this address. Also another address of us is here. If you type this address in your Telegram application, you can go to our channel and download thousands file of this simulation for your project, and you can use them in your project. Thanks for your attention. In the next video, I'm gonna talk about another type of DC microgrid that is related to this simulation. Bye for now.